Concrete is the most used material on the planet after water, and it's one of the most destructive to the environment. Today we produce 30 billion tons of concrete annually to build infrastructures because concrete is strong, durable, versatile and cost effective. It's a simple material made with cement, sand, stones and water, and cement acts as a glue to hold sand and stones together. However, concrete industry is responsible for 8% of the global greenhouse gas emission, and 90% of the concrete emission come from cement. Why? Because cement production involved with carbon intensive activities like mining, grinding and burning of limestone and clay. Because of the carbon emission, we are facing climate change effects such as global warming, extreme weather events, biodiversity loss and sea level rise. So, today concrete producers use industrial byproducts like fly ash from coal power plants to replace cement in concrete to reduce the carbon emission. But New Zealand is not an industrial country, so we need to find a new material to replace cement in concrete to reduce the carbon emission without compromising its performance. That's where volcanic materials come in. New Zealand is a volcanic country, so we have abundance of volcanic materials. Romans use it for their iconic concrete structures, but their effectiveness depends on the particle size. If particles are too large, they don't work in properly. If particles are too small, they need more energy for grinding. For my research, I collected different volcanic materials and brought them to the lab, grind them into different particle sizes and tested them to find the optimum particle size that can improve the strength of concrete. Then I made concrete cylinders and replaced cement up to 30% with that volcanic materials to determine the strength and durability properties. Based on the experiments, I found we can improve the strength by 40% and reduce the carbon emission by 20% of the traditional concrete. So we can break the wall of carbon intensive concrete with volcanic materials following Maori engineering principles like Kavishan. Thank you.